This is episode 5. We're now going to talk about representation of functions. So, let's say we had a truth table. Let's say we had a function. So, actually no, I'm going to make the truth table first. Let's say it's A, B, C. So 0, 1, 0, 1, 1, 0, 1. We do 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. Okay, now let's make a random function. Random outputs. 1, 0, 0, 1, 1, 1, 0, 1. Okay, so first thing we need to know is, we need to find out what the function is. A, B, C equals what? What does it equal? So, we have two ways to find out. There's something called sum of products, or SOP, and product of sums, POS. Sum of products means a sum of products. So x, y plus x not y, that's just an example of one, plus x, y not. So that's a sum of products. Product of sums is two sums or more times each other. So x plus y times x not plus y. That's POS. Okay? So, so now let's make the SOP of f. Okay, so this is how we do it. We look at the first one. By the way, sum of products is with the something you have to know. SOP is when it's 1, when f is 1. POS is when f is 0. Okay, so now let's make this function. So we do, it's 0, 0 for the SOP. We do 0, 0, 0 is 1. So that means A not, B not, C not, plus whatever the next one is. This is because if A is not, B is not, and C is not, so let's say they're all 0, so then it has to be 1. So this is all going to get flipped to 1. Then next, there's 0, 1, 1. So that's A not, B, C. The not is where the 0 is. Plus A, B not, C not, plus plus A, B not, C, plus A, B, C. This is the SOP of that function. Now let's do the POS. It's going to be the opposite. So we look at the zeros. A plus B plus C not times, since C is 1 in this case, it's therefore a not. Opposite of the way it was in SOP. So it's times A plus B not plus C times A not plus B not plus C. So that's the POS. Okay. Now we're going to talk about minterm and max terms. Minterms are just the ones, and it's characterized by a lowercase m. Minterms are the ones. Max terms are the zeros. That's just how they're called. So let's say we have an equation. So we have a truth table. A, B, 0, 1, 0, 1, 0, 0, 1, 1. So this is going to be, let's say it's 1, 0, 0, 1. So this is the M0. Starts counting from 0 and it goes up, not from 1, because it's 0, 0. This is going to be max term 1. This is max term 2. This is min term 0. So that's another way to, no, it's going to be min term 3. So another way to represent a function is to say min term 0 plus max term, min term 0 plus min term 2. Or we could say max term 1 times max term 2. Oh my bad, I made a mistake here, it's 3. Min term 0 plus min term 3. Okay. Another way to represent these is with this. A sigma, or whatever that is. So let's say it's 0, 2. No, let's say 0, 3. So this is the same as M0 plus M3, which is the same as A. Okay, it's the same as that. And so in this case, that would be A naught B naught plus A B. Another one, the opposite of that is product of sums, represented by a pi in Greek letters. So this is 1, 2 equals to max term 1 plus, no, it's times max term 2, which is equal to A plus B naught times A naught plus B. Okay? Okay, there we have that out of the way. Now we're going to have this is a much more complicated subject. It's easy to, once you know it, it's easy, but we're talking about logic gates. So the first one, the most simple one, is a NOT gate. You're going to have to remember what it looks like. So NOT, it's a triangle with a bubble over there. So this is NOT. So let's say this is 0, this is 1. It's 1, it's 0. Okay, and it's represented by a tag. So it's X naught. X naught. This is the output. Okay? Next, there's a OR gate. There's a curve by the back of it. So there's two inputs or more, X and Y. Let's say, for example, so this equals X plus Y. Okay? Next, we have AND. That's with a flat back. So it has X and Y, let's say. So that's X times Y. So we have to remember all the theorems and stuff that we learned before. So what you're starting to see is that you can turn functions into a schematic or like a diagram of a circuit. These are real circuits that can be created with electronics, and it's we don't have to understand how they work. Just understand. We have to understand like what they do, but not like why it's working this way, like what the electricity does and stuff. So let's continue. There's XOR gate. It's an OR gate with a little line in the back of it, the little curve in the back of it, in addition to it. So it's represented by a plus inside a circle, and it's also the same as x naught y plus x y naught. So you'd be able to draw an XOR gate with AND gates, OR gates, and NOT gates. You can do that. Okay. Next, there's NAND gates. It's an AND gate with a bubble at the end of it. This equals x, y, NOT. Okay. Next, we have NOR gate. This is different than a NOT. I made it kind of weird, but it's a NOR gate. So the curve at the end of it. So this is x plus y NOT. Next we have, finally we have XNOR. It's X OR and then NOR. So XY. This is also the same thing as equivalent. So let's say X naught Y naught plus X Y. So this is when X are the same, then it's true. Otherwise, it's not. Okay. I'll write what they are. Not or and SOR NAND NOR XNOR. Okay. And finally, no, not finally. So now I'll draw truth tables for all of them. So X, Y, so 0, 1, 0, 1, 0, 0, 1, 1. Okay, not, or, and, SOR, XNOR, NAND. Okay. This is how it works. Not. So this is not going to work for this one because there's two inputs. But OR is going to be 0, 1, 1, 1. AND is going to be 0, 0, 0, 1. XOR is going to be 0, 1, 1, 0. XNOR is going to be 1, 0, 0, 1. And NAND is going to be 1, 1, 1, 0. Okay. So now I'll try to show an example of implementing a function. So that's what we have. F equals f of b c equals let's say it equals a b plus b c not plus, okay, let's just do that. So first we have to draw the variables, so a, b, and c. Then we do, since a and b are like that, it's and. So it's going to be an AND gate over here. Going to here. Then there's going to be an OR gate after that because it's plus. And B and C, you can draw a bubble here to show that's branching off to reuse the line. And it goes into NAND because that's not. This is NAND. This is F. This is the function. We can extract the. Okay. We can see. So this is 0. This is 0. This is 0. So 0 and 0 are 1. 0 and 1 are going to be. Wait, no, they're all 0. So this is 0. And then 1 and or 0 is 1. So this is how you look at a diagram and figure out what the outputs are. Alright, this video is over.